a difference of squares again. So you have to decide what is going to be your value of A and your value of B, something that is convenient for you, such that you end up with A square minus B square, then you can do your A plus B times A minus B, something that is relatively easy. So any suggestions for value of A and value of B? In this case, what am I talking about? This is just your, okay, I wasn't thinking straight. This is just your value of A square, and here you have your value of B square. Okay, I was thinking about something else. So this is just simply using the expansion 13.5 plus 6.5 multiplied by 13.5 minus 6.5. Yeah, as straightforward as that. So A square minus B square, do the expansion. So 13.5 plus 6.5 is, what's that, 20. Whereas the subtraction, 13 minus 6 will give us 7, which is 140. Next one. Okay, then we have a couple of homework over here. We are encouraged to use these two. Right, where we already know where we have already memorized it. A plus B, when you square, you get A square plus 2AB plus B square. Likewise, you work the other way around. A square plus 2AB plus B square, you get A plus B square. So in part B, as mentioned, be very sensitive to numbers that are perfect squares, 9 and 4. Especially when they are attached to another perfect square, U square and V square. Because right now, I can rewrite my 9U square to become 3U square. Okay, so the first term is written like this, rewritten like this. Okay, the 12UV, no change. And we have 2V when we square it. Now this sets us up for the first equation, the first formula, A square plus 2AB plus B square. Okay, then we do a quick check. Hey, if I take 2 times of 3U, I get 6U. Then I multiply that with the 2V, I get 12UV. Hey, that's the same. So this is already of the format A square plus 2AB plus B square. So simply we will get 3U plus 2V. And we square this. And that's the answer. A plus B squared. Okay, just a quick check. Expansion is usually a bit easier. If we were to expand this, we get 3U A squared plus 2 times of A B plus B squared. There's a quick check. So we have 9U squared plus 12UV plus 4V squared. So it's the same. Then you can be sure your answer is correct. Next one, exercise 9. So we see perfect squares again for the first term and a constant term. This is our 7 square. And when we see that, you must be happy already, because you have A square minus something plus B square. So that sets us up for this, A square minus 2AB plus B square. Then 2 times of T times 7. That will be 14T. Okay, so it is still of the same format also, but this time it's the second formula that we can use. So this is T square minus 14T plus 7 square. T minus 7 square. Okay, so when you write this in your mind, do a quick check. T square minus 2 times of T times 7. That is our second term. 2 times of T is 2T times 7, 14T. So minus 14T plus 49. And the next one, we have big coefficients over here. Then our 45, oh, it's not a perfect square. 20 is also not a perfect square. But if you give this to a Sec 1 student, The step 1 student will say, hey, I can factorize out 5. Factorize out 5. That's probably all that they can do. So 9m squared plus 12mn plus 4n squared. Then it will stop there, because they think cannot factorize it. But now you know, hey, this is quadratic. Inside this, I can use my multiplication frame. Your 9m squared, your 4n squared, so on and so forth. Hey, but we have another trick up our sleeve. We notice that, oh, it's a perfect square. Another perfect square. Multiply with perfect squares again. Looks like the first term and the last term, they are all perfect squares. So let's check. If I were to square root 9m squared, I get 3m. If I were to square root 4n squared, I get 2n. So what is 2 times 3m? That's 6m. Then 6m times 2n. That is 12mn. Oh, it's the same. Then you should be happy lah. Okay, I can use my formula now. So the answer, this will be 5 times of 3m squared plus 12mn plus 2n squared. So within the square bracket, we have our perfect square again. 3m plus 2n. And you square this. Coefficient of q squared. So these values are perfect squares. That's hinted by you. And then they are all attached to perfect squares again. P square and q square. So my first term can be rewritten as 11p squared minus 132 pq plus 6q. Let me square this. So it looks like I have a perfect square here, another perfect square. If I can confirm that this is of the form 2ab, then I can use the formula again. So because these numbers are now a little larger, but still manageable. 11 times 2, 22. 22 times 6, 132. So yes, and then we have the p times the q. It is, I have confirmed it already. It is of the form a minus b squared. So 11p minus 6q squared. I think the last question for your homework. Like it's similar to a question that we did yesterday. Instead of a straightforward single term as the a square term, and in this case we have a single term, 49, for the b square term. We see that our a square can actually be broken down into x plus y, but don't worry about that, just treat it as one term by itself. Okay, so I have the form a square minus something plus b square. Well, in this case, the a value is x plus y, the b value is 49. If I can confirm that the center term is actually 2 times of a times b, then I can use the formula again. So let me do a quick check. 2 times of x plus y times your b, which is 7. Yeah, I get 14x plus y. So it's the same. Of course, with the sign difference. So this means that this is now rewritten as a minus b. Then it's squared. So a has a value of x plus y minus b. b itself has a value of 7. Let me square this. Done. This is our a. This is our b. ABCD with dimensions as shown. AD is 5p minus 2. Then there's a perpendicular distance, 3p plus 1. And it further tells us that the area is 12p squared plus 13p plus 3. So if you have forgotten your formula for finding the area of a parallelogram, you can always derive it by yourself. Okay, this yellow triangle, you chop it off, you cut it out, and you place it over here. It is the same triangle. And now you end up with a rectangle. You can find the area of a rectangle easily. The base, length and breadth. So the length, which is CD, we don't know that. The breadth will be the perpendicular distance. And then that will give us the area. Okay, so that's a quick recap on finding the area of a parallelogram. Basically, this distance times the perpendicular height, which you have. Okay, back to the question. Factorize completely 12p squared plus 13p plus 3. So we will need our multiplication frame for this. With the quadratic term, the square term, 12p squared in the top left hand corner, and then the constant term in the bottom. Okay, now we have to find the dimensions of this box. The easier place to start is with this constant 3. So 3 itself has two factors. It is a prime number. I'm happy to see that. So let's say 1 and 3. 1 and 3 over here. Okay? So now the challenge is my 12p squared, because I have many options. 12 is a composite number. It is not a prime number. It's a composite number. So I have to try 1 times 12, 2 times 6, 3 times 4, and the other way around, and then negative. Right? That is for the 12p squared. But, do you think this is going to be related to the area of this parallelogram? I mean, do you think it is going to be related with the way we find the area of a parallelogram? I would think so lah. Because this 12p squared plus 13p plus 3 is given to be the area over here. And earlier we mentioned that, hey, to find the area of a parallelogram, we take the base or the length times the perpendicular height. Right? So we are expecting two terms multiplied together to give us our area. Kind of like what we expect to see when I factorize out the area. Okay? This is what I'm going to expect. Perhaps one of them is going to be the length. Then the other will be the perpendicular height. Is it reasonable to go along that line of thought? Quite reasonable. Perhaps one of them is the length, the other one is the perpendicular height. Well, I don't have the length, but I do have the perpendicular height of 3p plus 1. So instead of starting with p and 12p, then I go down the line 2p and 6p, so on and so forth. Let me try to use what is already in the question, 3p plus 1. I mean, that's my hunch. I think they will set up the question that way. Let me try to put a 3p over here so that I end up with a 3p plus 1. If this is 3p, then this must be 4p. And now I'm ready to fill in the other two blanks. Let's start with the top right hand corner. 4p times 1. This area is 4p. The bottom left hand box, 3p times 3. I get 9p. Okay, so I check. The p terms added up is 13p. Same. So my hunch is correct. So here we have 3p plus 1 being the perpendicular height, and the other dimension is 4p plus 3. And by doing so, you know now that the length CD is actually 4p plus 3. Okay, then using your answers in A, find the parameter of the parallelogram. Well, quite simple. Parameter will be 2 times of 5p minus 2 plus 4p plus 3. Okay, there's a 4p plus 3 at the bottom, 4p plus 3 at the top. Left side there's a 5p minus 2, right side also 5p minus 2. That's why we put a 2 times. Of course, you can go ahead and add all 4 of them up. So 9p times 2, 18p. We have a positive 1 times 2 plus 2. So this will be in cm. Okay, they didn't ask us to factorize, so no need to factorize out the 2. Leave it in the expanded form, the simplest form. Okay, given further that it is a rhombus, find the value of p. So rhombus means that all sides same length. So if all sides have the same length, that implies that 5p minus 2 is the same as 4p plus 3. And then go and solve for p, will be 5 cm. Okay, now next question, exercise 12. The nth term of a sequence is given by this. So depending on the position that you want, if you want the first term, so n will be equal to 1. If you want the second term, n will be equal to 2. And then you can see that the value will change according to this formula. So find the first 4 terms. There is not a lot of space, so let's just try to write it neatly. T1, that's the first term, term number 1. I'm going to do a substitution. So 1 cube plus 3 times of 1 square plus 2 times of 1. Okay, and this gives me 1 plus 3 plus 2, which is 6. Then T2, 2 cube, 2 square plus 2 times of 2. So calculate 8 plus 12, 20 plus 4, 24. Term number 3, 3 cube, then plus another 2 times of 3. So 27 plus another 27, 54 plus 6, 60. Final one, T4. Term number 4, 4 to the power 3, 3 times of 4 square plus 2 times of 4. Okay, I need a calculator. 64, 48, 8, 120. So here we have the first 4 terms, which you can easily do by yourself also. Okay, then the next part, factorize n cubed, 3n squared plus 2n completely. 3 terms, there are 3 terms involved. We are going to use the multiplication frame. But before that, same thing, look for common factors first to simplify your work. So n cubed, n squared, n. Yeah, n is a common term. So this gives me n squared plus 3n plus 2. Then factorize out whatever is in this big bracket with your multiplication frame. n plus 2, n plus 1. Okay, let's put them in ascending order. N plus 1 and n plus 2. N plus 1, n plus 2. Okay, so now we have the factorized form. So explain why all the terms in the sequence, they are multiples of 6. So you see that for the first 4 terms, right? They are all multiples of 6. Then the usual way that we prove that something is a multiple of 6 is by factorizing out 6. But we see in this case, there's no common factor of 6. You cannot factorize out 6. So we need to use our second approach. The other approach is that we consider odd and even numbers. What happens when n is an even number? What happens when n is an odd number? From there on, you see whether we can form the factor 6 out. Keeping in mind that 6 is also made of 2 times 3. Okay, I'll give you a little bit of help over here. This will be your homework. You go and try it out, go and crack your brain. Can be done. Kind of like an IQ question. Okay, and this is the hint. When n equals to odd. Okay, then do the substitution. You see what happens. You substitute it back inside here. Then when n equals to even, and then same thing, you substitute back inside here, you see what happens. In both cases, you should end up with 6 is a factor. Okay, in both cases, whether it's odd or even, you will find that 6 is a factor. And then the second clue, this is the first clue. The second clue is that 6 itself is made of 2 times 3. So maybe you will not see 6 appearing. Maybe you will see 2 multiplied by 3. Like if you see that happening, then confirm 6 is a factor already. Okay? So this, go and try as your homework. Don't be too concerned about the presentation for this particular question, because it is not going to be an exam question. It's not going to be a test question. This one is really just to check your understanding only on how you think. Okay, then the final question in this set of notes, exercise number 13. So we have what appears to be like our multiplication frame. You know, we always draw 4 boxes, right? And they are related to the area. Same thing over here. The areas are 21ax, 7bx, 6ay, and 2by. So they want you to factorize this. Wow, that it doesn't really look like there are common factors. But we can consider pairing them up, like what we have learned in Sec 1. Okay? Or, if you want to go by using a multiplication frame, that means, for example, 2by. In order to obtain 2by, perhaps this will be 2b and this will be y. So you can go and try out the combination. Maybe it is supposed to be 2y and b instead. You can go ahead and do that. But I think the easier way is just to pair them up. Our Sec 1 approach. So here we end up with 7x as the common factor for the first pair. 3a plus b. Whereas in the second pair, we have 2y, 3a plus b again. So the common factor is 3a plus b, 7x plus 2y. So with this, find the length of AR and DP. AR, DP. Okay, then we have to fill in the dimensions using what we have just factorized. So this total area, this total box, it has an area of, dimensions of 3a plus b as well as 7x plus 2y. So it is your job to find out what goes where. Let's start with the 3a plus b. The 3a plus b term is going to be either here, 3a plus b, or it is going to be over here, 3a plus b. Let's see what makes sense. So it is really a bit of trial and error over here. Okay, so go ahead, try and error for the remaining 1 minute of the lesson. I'll be doing it together with you. Then we will check our answer.